Hi, welcome back to our Honors Geometry playlist. On this video, we'll look at 4.8 coordinate proofs or geometric proofs in the coordinate plane. So on this video, we want to prove some theorem or some conjecture using our coordinate grid, and we're going to use our distance formula. Now you can use the distance formula. You might need the slope formula. And there are even some proofs where you might need to use the midpoint formula, but we don't do any of those in this video. So our first proof here, I want to prove that this is an isosceles triangle. So I need to know, first of all, what am I trying to prove? I'm trying to prove that this triangle is isosceles. What does that mean? That means that the triangle has two congruent sides. I'm trying to prove that my triangle has two congruent sides. And I'll start with my given statement. I'll start with the information that was given to me, is that A is -5, 1. B is -1, 1. And C is -3, 5. And I want to prove that it's an isosceles triangle. So that was my given statement. I'm going to shrink this down a little bit in size. There we go. So that was given. If I were to plot this triangle, 1, 2, 3, 1, 2, 3, 4, 5. And -1, 1. C, B, and A. I want to prove that my triangle ABC is isosceles, and I'm going to use my distance formula to do that. Now, what I would encourage you to do is to show at least your very first step where you set up the problem, and then your final answer for this distance formula. So if I want to find the distance of AB, I would start by saying AB equals, and I would find my distance formula. So that would be -1 plus 5, or -1 minus -5 squared, plus 1 minus 1 squared. So this would be the square root of 16, which is 4. For AC, same procedure here. I would want to find the distance between A to C, so -3 minus -5, or -3 plus 5 squared. And then I have 5 minus 1 squared. So this would end up being the square root of 20, which is the same as 2 root 5. And BC, if I find the length of BC, I have -1 plus 3 squared plus 1 minus 5 squared. So that would be the square root of 20 as well. And I know that this is true because I used the distance formula. So by the distance formula, I can claim that these three sides have the lengths of 4, square root of 20, and the square root of 20. Okay, so now that I have these sides, I can say that AC is congruent to BC by by the definition of congruent. And then if those are congruent, then I know that triangle ABC is an isosceles triangle because I know that by the definition of an isosceles triangle, if I have two congruent sides, I must have an isosceles triangle. All right, let's try another isosceles triangle example. This one's going to be an isosceles right triangle. So I'll have all the same steps as before, but I need to prove a right angle as well. So I get A for -1, B is 5, 1, 2, 3, 4, 5, 6, and C is 1, 3. So here's my triangle ABC, and I'm going to use some intuition here to say that I think angle C is the right angle. So I'll start with my given statements. So given those coordinates, I want to show that this is isosceles right. Well, if this is isosceles right, the only two options that I have for the congruent sides would have to be AC and AB. Or I'm sorry, AC and BC. So let's show that AC and BC are congruent, or at least equal, by our distance formula. So AC would be 4 minus 1 squared plus -1 minus 3 squared. That would be 9, and (16), which would be the square root of 25, which would be 5. BC would be 5 minus 1 squared plus 6 minus 3 squared, which would be, again, 5, if I were to simplify that. So that is my distance formula. By the distance formula, I have AC and BC are equal, which means that AC must be congruent to BC by the definition of congruence. And now the very last thing I need to do, I've got my isosceles triangle. I need to prove it's a right triangle. So I need to show that angle C is a right angle. Well, how can I show that angle C is a right angle? I could show that AC and BC are perpendicular by showing that their slopes are opposite reciprocals. So what I'm going to do here is I'm going to show that those are opposite reciprocal slopes with my slope formula. So AC would be 3 plus 1 over 1 minus 4. So this would be -4/3. And the slope of BC, maybe I'll do that in a darker color. BC would have to be 6 minus 3 and 5 minus 1, which would be +3/4. So by the slope formula, I found the slopes. They are opposite reciprocals, which means that AC must be perpendicular to BC by the definition of perpendicular. And then I need to show next, since they are perpendicular, then I can claim that angle C is a right angle. And once I've said that angle C is a right angle, by the definition of a right angle, then I've proven that I have two congruent sides and a right angle, which means that I must have, finally, triangle ABC is an isosceles right triangle. By the definition of what it means to be an isosceles right triangle. Okay, so those are my coordinate proofs about the isosceles triangles. I've got some coming out for congruent triangles in just a few minutes, so check those out.